Okay, evaluating function notation notes. So this is 1A, our first official learning target here. And function notation is just another way of describing a function. It's something that you've probably seen, but maybe aren't able to put a name to. But essentially, function notation uses f of x instead of y. So again, this is pronounced f of x. It stands for function of x. And we use that instead of y. And it especially becomes valuable when multiple variables get involved. So whenever we evaluate functions, we'll be plugging in x, which we usually call the input, to find f of x, which we refer to as the output. And it's important to remember to always use parentheses when plugging in x. So let's take a look at an example of function notation. So we're given the function f of x, remember this means the same thing as y, equals 3x minus 4, and we're told first to find f of 5. So to find f of 5, it means we're plugging in 5 for x. So if we're finding f of 5, that means we need to replace x with 5. So that'll be 3 times, replace x with 5, minus 4. And this is just function notation, or f of 5, is basically saying this is what the y value is going to be equal to when x is 5. So you just simplify the right side. This isn't like f times 5 or anything. This just means f of 5. Basically means the same thing as y. So 3 times 5 is 15. 15 minus 4 is 11. So f of 5 equals 11. So meaning when I plug 5 into this equation, my output is 11. Next, we have f of negative 1. So that means we plug in negative 1 for x. So it's 3 times negative 1 minus 4. And we just simplify. 3 times negative 1 is negative 3. Negative 3 minus 4 is negative 7. So f of negative 1 is negative 7. All right. So you've got another example here. So why don't you go ahead, write it down, give it a try on your own. Okay. If you're not done yet, pause the video. But if you are, let's start by finding g of 2. So that means we are just plugging in 2 for x everywhere that x is. So g of 2 is going to be 1/2 times 2. Notice how I'm using parentheses when I'm putting that 2 in. It just helps with multiplication. Minus 5. 1/2 times 2 is just 1. Minus 5 is negative 4. So g of 2 is negative 4. Next, g of negative 5. So we have 1/2 times negative 5 minus 5. We're plugging in negative 5 everywhere that x is. 1/2 times negative 5. Remember, multiplying fractions, just multiply straight across. So we get negative 5 over 2 minus 5. These are like terms. We need to combine them. To do so, we need a common denominator. So let's rewrite negative 5 as negative 10 over 2. Negative 5 minus 10 is negative 15 over 2. Okay. So that's function notation when you're just using numbers. There are situations where you'll use function notation where the thing you're inputting, your inputs, the thing inside parentheses, is not a number. So in that scenario, depending on whatever it is, instead of plugging in a number, we'll be plugging in an entire, we call expression for the input to find f of x, which again is just our output. And again, as with numbers, remember, always use parentheses when plugging in our expression. I'm just realizing I misspelled parentheses up here. It's ES. So let's do one together. So we have g of x is x cubed minus 4x squared. First, we want to find g of a squared. So g of a squared. So that means every time we see x, we replace it with a squared. So make sure to use parentheses. So we have g of a squared equals a squared to the third minus 4 times a squared squared. We got to simplify. So remember, exponent to an exponent. In those cases, you always want to multiply the exponent. So 2 times 3 is 6. Same here. 2 times 2 is 4, so we have a to the 4th. And these are not like terms since the exponents are different, so there's nothing more to simplify there. So g of a squared is just a to the 6th minus a to the 4th. Let's do another. So now we have g of b over 2. So again, every time you see x in the equation, now we're replacing it with b over 2. So g of b over 2 equals b over 2 cubed minus 4 times b over 2 squared. And we have a fraction here with an exponent. So this exponent has got to apply to both parts of the fraction. So it'll be b cubed over 2 to the third, which 2 times 2 is 4, times 2 is 8. So 2 to the third is 8, minus 4 times b squared over 2 squared, which is 4. So let's simplify further. 4 times 4, or 4 over 4 will cancel. So we just have negative b squared there. And over here we have b cubed over 8 still. There's no canceling happening there. And these are not like terms. So we're done. So notice in function notation, when you're just plugging in a variable, or what we call an expression, sometimes your solution is not just a number, it's also an expression. Okay. So why don't you try now a couple of problems where you are using expressions. So take a look at this problem. We have, given the function f of x equals 3x minus 4, find f of a plus 1 and f of negative b. So pause the video and try it on your own. All right, we're back. I'm going to go through these, so if you're not done, pause the video again. So f of a plus 1 means every time we see x, we're replacing it with a plus 1. So f of a plus 1 will be 3 times a plus 1 minus 4. So this is where using parentheses is super important because that 3 needs to be applied to both a and 1. So 3 times a is 3a, 3 times 1 is 3. We've got two like terms here, 3 and negative 4. 3 minus 4 is negative 1. So f of a plus 1 is equal to 3a minus 1. And we have a second problem here with negative b, same idea, but we're just plugging in negative b every time there's an x. So f of negative b, or the output, when negative b is our input, 3 times negative b is negative 3b, and then we just have minus 4. And not like terms, so we're done. Okay. The last thing we're going through here is composite functions. So composite functions are essentially when you have a function within a function, which is a little odd, but I think it'll make more sense as we go through it. So composite functions we describe as the combination of multiple functions. They can be written in two ways, with an open circle like this. And this is described as f of g of x. So notice previously function notation we just described as like f of x. When there's two, you say f of g of x. Or the way I prefer it is like this, f of g of x. So on the inside we have like our traditional function notation, just g of x. but we're taking a function of that function, so f of g of x. So I have an image down here that kind of describes how this works. So it's like you're putting things into two functions. So if we put something into the function f, it gives us something. Then we have to put that same thing back into function g, which gives us something else. It's like you're plugging things in to more than one function. And I think as we do an example, that'll make a bit more sense. So here we go. So given the f of x equals negative 4x plus 5, and g of x equals 2x squared minus x plus 12, evaluate the following composite functions. So here we have g of f of 2. So the way you want to do these is you always want to work from the inside, then out. So start on the inside, then work out. So we are going to start here with just f of 2. So our function f of x is negative 4x plus 5. So f of 2 would mean we're just plugging in 2 for x. So we have negative 4 times 2 plus 5. And then let's go ahead and simplify that. Negative 4 times 2 is negative 8. Negative 8 plus 5 is negative 3. So we've determined that f of 2 is negative 3. So we'll call that our first step. Our second step, notice we're finding g of f of 2. But we've determined f of 2 is negative 3. So what that would mean is g of f of 2 is the same thing as g of negative 3. So it's substitution. They're the same thing, so we can substitute. So now what we can do is we can plug in negative 3 into g of x. So for the sake of space, here I'll just go over here. So negative 3 for x is 2 times negative 3 squared minus negative 3 plus 12. So notice how we're working from the inside and then out. Now this is just like previous problems where we can solve this. So let's go down here. So negative 3 squared, negative times negative is positive, so we get positive 9. Minus a negative 3 is the same as plus 3, plus 12. 2 times 9 is 18, plus 3 is 21, plus 12 is 33. That's poor handwriting. So there you have it. So g of f of 2 is 33. You start from the inside, then work your way out. Okay. This one's a little odd here. So we have f of g of x. So we're not plugging in anything on the inside into g of x. Because if we plug in x, we just get the same thing. So what we essentially have here is instead of thinking of it as f of g of x, we already know what g of x is equal to. It's 2x squared minus x plus 12. So what we can do is we can substitute g of x for 2x squared minus x plus 12. So kind of funky looking. So what we're doing then is we're plugging in 2x squared minus x plus 12 for x, which is a little weird. So if we're plugging that in for x, we got to plug it in for x here as well. So negative 4 times 2x squared minus x plus 12. And then we have that plus 5. And then you just multiply that 4, distribute it. So negative 4 times 2x squared is negative 8x squared. Negative 4 times negative x is a positive 4x. Negative 4 times 12 is negative 48. And then we have plus 5. Then it's just a matter of combining like terms. So negative 48 and 5, those will add to negative 43. And everything else is just as is because there are no like terms. So kind of a weird one. Okay. Last one here, we have the other notation, f of x, which means the same thing as f of x, so you can write it in either way. So what this is saying is that we are now plugging in f of x for x in f of x. It's a little weird. So we know that f of x is equal to negative 4x plus 5. So what we're going to do is we're going to plug in negative 4x plus 5. This is the same thing as saying this. So we're plugging in negative 4x plus 5 for x in f of x. So that'll give us negative 4 times negative 4x plus 5 plus 5. So then you simplify. Negative 4 times negative 4 is 16x. Negative 4 times 5 is negative 20. And negative 20 plus 5 is 15. Okay. Odd one. All right. You have 3 more here. So what I would like you to do, again, pause the video, write down the problem, go ahead and try these 3 on your own. This is your last check here. And when you're done, unpause the video and check the answers. I'm not going to read through them as I normally would. There you have it. Here are your solutions. Thanks for watching.